We're given two functions, the functions f and g, which are defined as follows. And we are asked to state the equation of the vertical asymptote to the graph of y is equal to g of x. So what is the vertical asymptote of the function g of x? So what is an asymptote? An asymptote is simply a straight line which a function approaches. That line can be vertical, or it can be horizontal, or it can even be another line altogether. But a function needs to approach it and get closer and closer to it without ever reaching it. So to find the vertical asymptote of the g of x function, what we're looking for is what value of x can this function approach more and more, but can never reach. Now, looking at this function, we can see that the log of x is the only part of this function that contains x. There is a hint given to us where x has to be greater than 0, and really that's because the log of 0 does not exist. The value of x where this function breaks is at 0. Therefore, the vertical asymptote of this graph is x equals to 0, and that is all you need to write down. For part B of this question, we're told that the graphs f of x and g of x intersect at two distinct points. We are asked to show that at the points of intersection, that x squared minus 2dx plus 9d is equal to 0. We're then asked to hence show that d squared minus 9d is greater than 0, and to then find the range of possible values of d. If we plot the functions f of x and g of x, you can see that these graphs do indeed intersect at two distinct points. And what we need to do is write down something about these 2 points. Now we know when these two graphs intersect that they are equal to each other. And so that's exactly what we're going to do. We're going to set the two functions to be equal to each other and then see what we end up with. For part B, we're being shown that the graphs of f of x and g of x are intersecting at two distinct points. And we're being asked to show that at the point of intersection, x squared minus 2dx plus 9d is equal to 0. So what we do is we set these two functions equal to each other because at these points of intersection, their outputs are equal to each other. So we have the log of 2x minus 9 is equal to 2 times log x minus log d. Now obviously what we're going to be doing here is trying to get rid of the logs. So we're going to have to try and make it that it'll be log something on the left hand side of the equal sign and log something on the right hand side of the equal sign. The left hand side of the equal sign is already like that, so that's good. The right hand side has 2 logs in it, so we need to tidy that up a little bit. We need to remember that 2 log x is equal to the log of x squared, and we substitute that in for 2 log x. So on the right hand side we end up with log of x squared minus log of d. This simplifies down. Remember that a subtraction in logs becomes a division when you put them together. So we end up with the log of x squared divided by d. Now we have a log on the left hand side and a log on the right hand side, and we can take the exponent of both sides. And what this does is it ends up essentially cancelling out the logs. And then what you end up with is 2x minus 9 is equal to x squared over d. And then we just need to tidy it up. We multiply across by d, and we move the x squared over to the other side. And we end up with x squared minus 2dx plus 9d is equal to 0. Just as a small aside, what you should kind of think about this little function, this little equation, is that this function describes the difference between the two functions, the difference between the output of the two functions. You can see on the graph that the difference between them grows and shrinks to these points of intersection, and that's what this function is describing. That at any value of x, you can now calculate what is the difference between where the graphs are. For part 2, we're asked to hence show that d squared minus 9d is greater than 0. Now already alarm bells should be going off. You have a quadratic function and you're being asked to show that d squared minus 9d is greater than 0. You should be thinking of the discriminant. And that's exactly what you need to do. The discriminant of a quadratic function is b squared minus 4ac. In our case, the discriminant then is minus 2d all to be squared minus 4 times 1 times 9d. We have 2 intersection points, so we know that our discriminant is going to be greater than 0. So we can set our discriminant greater than 0, and we multiply it out. Minus 2d squared becomes 4d squared. 4 times 1 times 9 times d becomes 36d. So we've got 4d squared minus 36d is greater than 0. And then we can divide across by 4, which then gives us d squared minus 9d is greater than 0. Finally, for part 3, we're being asked to find the range of possible values of d. Obviously, this is going to have something to do with what we just solved. So we know that d squared minus 9d is greater than 0. So what values of d allow that function to remain true? Now, if we factorize what we have, we take out a d, we end up with d times d minus 9. Now, in order for that to be true, let's think about this. If d is less than 0, so if d is a negative number, you'll end up with a negative number outside the brackets times by another negative number. So if d is negative, d minus 9 is still going to be negative. That then will give a positive number. However, we're told that d is a positive real number, so we know that's not possible. The only other option is for d to be greater than 9. If d is between 0 and 9, then you'd have a positive number outside the bracket multiplied by a negative number inside the bracket, so that's not going to work. The only way it can be true is that if we subtract 9 from d, that resulting number is not negative, so d therefore must be greater than 9. So d greater than 9 is our final answer. Finally, for part C, we're told that the graphs intersect at x is equal to p and x is equal to q, where p is less than q. And we're told that in the case where d is equal to 10, what would be the value of q minus p? So what would be the difference between those 2 points? And we're asked to express our answer in the form of a square root b, where a and b are positive real numbers. Now, if you remember back to part B, I said that little equation, that describes the difference between those 2 functions. That is a quadratic equation, and when the difference is equal to 0, those are the roots of that quadratic equation. In this case then, the roots are p and q. So what we need to do is find those roots and find the distance between those roots. Substituting in 10 for d, we end up with x squared minus 20x plus 90 is equal to 0. And what we need to do is find the roots of the equation. So we use the quadratic formula where x is equal to minus b plus minus the square root of b squared minus 4ac all over 2a. Putting some numbers into that and solving a little bit, we end up with x is equal to 20 plus or minus the square root of 400 minus 360 all over 2. And solving again a little bit, that we have that's 20 plus or minus 2 square root 10 all over 2. Simplifying again a little bit, that's 10 minus the square root of 10, or 10 plus the square root of 10. The difference then between those 2 points is going to be 2 times the square root of 10. So if we have a point 10, and we're saying that the roots are minus root 10 and positive root 10, obviously then the distance between those 2 points is 2 times that difference, the square root of 10. So we have 2 square root 10 is equal to that distance. Thank you so much for watching. I hope this tutorial made things clearer and helped you tackle this question. Don't forget to like, subscribe, and hit the bell to stay updated when more questions are answered. If you have any questions or need any more help, please drop a comment below and I will get back to you. Until next time, keep practicing and good luck.